Good. So thank you, everybody, for coming today. I'm very happy, especially that you stayed after the food. This is a very good thing. So today is our first tech talk or meetup for the Egyptian community in technology in Berlin. So welcome, and thanks for GetYourGuide for hosting our event. And I don't want to take too long from you, so this is the agenda for today. So first we're going to have an intro from Matthew. He's our VP Engineering at GetYourGuide. And then we have CI/CD by Mohamed Radwan. After that, we have demand time series analysis and forecasting by Baddar. And then site reliability engineering by patterns by Youssef. And then we can have more networking and more pizza. So yeah, I will hand over now to Matthew. Thank you.
Cool. Thanks, everyone, for joining. Welcome to GetYourGuide. I have a very good news. This is not going to take 20 minutes, but I have, of course, time for questions. So we'll try to keep it interactive so we get as quickly as possible to the real meaty content of tech. Very interesting topics. Very excited for you to be here. My background is in computer science, also in data. I've been a data scientist not so long time ago. But today I'll talk about engineering in general. I'll GetYourGuide, tell you a little bit about what we do, what maybe we do differently or the same. And I've been with the company for about 2 years. I spent some time in Silicon Valley before. I worked at LinkedIn, and I'm originally from France. So who is GetYourGuide? So you maybe heard about us. Maybe I'll tell you a little bit about who we are first and then what we do. We are a startup here in Berlin. We also have a Zurich office. The company was actually originally founded in Switzerland as a spin-off of the ETH Zurich, a very interesting school for engineering. We've been growing a lot in the last 6 months as well. It's about 60 people in engineering. That's actually not with product and design. So with entire tech team is a little bit bigger. Very diverse as well, 25 different nationalities, Egyptians as well, obviously. But yeah, like really proud of the team. Here are a few pictures of some things that we've been organizing also as well. So GetYourGuide is a marketplace for tools and activities. So if you are going on vacation, let's say in Paris, we offer a lot of things that you want to do. Maybe some of the big things like Eiffel Tower tickets. We have, of course, some of these big hitters, but also interesting things to do like sand cruises. Here in Berlin, we have also the big museums. And we offer the whole range all the way from activities that take 1 hour to even multi-day tours, 5 days, Machu Picchu. So essentially, what we try to do here at GetYourGuide is think about the real interesting part of travel. So, show hands, who of you remember which hotel you stayed in your last vacation? Okay, a few hands. Who remember which airlines you actually took to go there? A few hands. Who remembers what actually you did when you went to the destination? What activities you did? What restaurants you went to? That's actually, for us, we think this is the interesting part of travel. So we like to solve this problem of taking an industry that is very offline. If you think about it, our main competitor is the good old ticket booth that you go and wait in line for your ticket. We think this is something that is a very bad experience, and we think that we can use technology to solve this problem. Bring all of those great activities at the best price online. And eventually, basically what it means is that we provide a offering of the various things you can do. And you have an iPhone, Android app as well, but also a website where you can browse for a specific destination. Once you get to find what you want to do, you book, and you enter at this point your what we call a post-purchase. So that's also something that we try to optimize as much as possible. So if you want to cancel or if you have a problem with your tour, we have a customer service that helps you, for example, find a meeting point and so on. And if you're happy, then you get back to getting more recommendations, leave some reviews as well for other customers, and the cycle repeats. So this is a bit of a high-level picture, but I'm going to talk about maybe some of the more, I would say, maybe practical or problems that we are solving. So we have a very complex database of products. You can find 30,000 things to do, and one of the things that we do is organize this database in the best way possible, so you find what you're interested in. So with search, with recommendations, our goal there is to take your intent. Maybe you know what you're looking for, but maybe you don't, right? So in that case, how do we manage those recommendations for you? And the way we do this is a lot through A/B testing. You're probably very familiar with A/B testing if you're working in the web space. It's something that we do a lot here, also on the statistics side, to really understand what we're doing. Then when it comes to one key problem that we found that people have a lot when they go on vacation is last minute. So it's very important that if you go in front of the museum or in front of the activity, you are able to go on GetYourGuide and find the tickets to get in, and especially if there are no other tickets available. So real time is really important for our customers. So we try to connect directly with our suppliers. So for example, we have a connection with the TV tower. I mean, the latency takes like 6 seconds. Like, can you believe it? To get real-time availability to the TV tower here in Berlin. So when you are in front of it, you can find those tickets on GetYourGuide, and that means that we are managing a pool of suppliers. Sometimes it's pull, sometimes it's push. There's different mechanisms that we obtain tickets, obtain availability, and we develop a standard set of APIs for that. And finally, more on how do we actually bring customers to GetYourGuide. We are very involved in doing advertisement on Google through our Google AdWords technology. So we have developed tools and techniques to scale our advertising to the millions of destinations and the millions of customers that are going through a very diverse set of destinations. And it's a really interesting problem because you get to solve across the world. You have a lot of destinations, but you also have a lot of source markets. So for example, you advertise differently to an American customer going to domestic, or a European customer going to Dubai, or an Asian customer going to Australia, or an Asian customer going to another country in Europe. So that level of complexity is something that we take care of at scale on our using machine learning and on Google AdWords. So these are some of the problems that I wanted to highlight, or the things that we do here. We also have a blog. So this is a bit the external view of what we do. It's of course interesting to share some of the insights on the technology side. There are also articles and so on that tells you a little bit about our culture. And talking about our culture, this is more how we develop software than what we develop. But our philosophy here is to work with small cross-functional teams. So teams are composed of various functions, product managers, engineers, data analysts, data scientists working together. So this is how we work, and we always try to use data as much as possible to inform our next steps. A/B testing, experimentation as well. So when you don't know an answer to a question, either you test it through an A/B test or you analyze data that tells you maybe from historical behavior, from past behavior, what's going on. Try to ship code as often as possible, many times a day, using also open source technologies, cloud technologies. And here's a few nice logos. Tell you a little bit about how GetYourGuide tech looks like today. Putting into two categories. One is a bit what we kind of brought us so far, and here on the bottom, some of the things that we are using that are a little bit more more recent. That are maybe some of them are still being evaluated. Some others are already adopted. We actually just released that tech radar. We're gonna put that a bit more public as well, but that brings even more level of granularity. So we've started the company with a PHP LAMP stack. We still have a lot of PHP, but that has become much more diverse in the last couple of years. Happy to maybe if you have some specific questions about the technology that you're really interested in, but we definitely are in the middle of a transition to break down a PHP monolith to services, and start to work a lot more with containers, with Kubernetes, and so on. On the data side, we started with a traditional PostgreSQL data warehouse, and we've been moving to Spark and Scala for the last year as well. So these are some of the trends that are sort of going on at the moment here at GetYourGuide. You're probably familiar with most of those stacks, but happy to talk about it more if you're interested. That's it. Very short description of what we do. Some of the challenges we face here, they are very diverse. That's one thing that I learned last 2 years. I kind of like joined GetYourGuide with, okay, I'm going to be working on search recommendations and entity and tagging. I eventually worked on performance marketing and a lot of other things. So that has been one of the cool thing that GetYourGuide offers, that really very large diversity of things that moves the needle at the end of the day. Please check out our open positions if you're interested. Happy to answer any questions about the presentation or anything you may be wondering around, or maybe where we get our pizzas. Yeah, I think we have this mic that you maybe want to use for the remote folks. Here we go. Just speak in the big box.
Okay, thank you for the presentation. I enjoyed it very much. I wonder if you can share some of the part of the journey for the conversion from the monolith to the microservices.
That's a very good question. I think we should do this talk in 6 months. We'll actually have some lesson learned. I mean, it's a bit early. It's a bit early for me to talk from a position of strength. I do think that it's a long project. I wouldn't do it if I don't have the some experts in house and decent project management, because quarter after quarter you need new goals, and for me, one learning that I see so far is that you need to emphasize that it's more about breaking down your monoliths in a business way, so that each unit is a use case, rather than really talking about microservices. For me, it's first modularization rather than really technology microservices. So that's, if you have one, but you don't talk about modularization of your code in units that make sense, that the team can own, it doesn't make sense to do microservices. So that's something that I learned, and I've been pushing for that a lot more, rather than just, okay, what are the technologies? Because we definitely, when we embarked into microservices, you don't get to anywhere before you even really have a good understanding of a lot of new technologies. So it took us basically 6 months just to get to a development environment, the developer environment with all of those tools, Kubernetes, Docker, that we didn't use before, and we haven't even wrote the microservices yet, right? That's kind of when we have now, but you realize that you've been spending a lot of time setting things up. So that's one thing I can say at this point. I don't think we are the fastest at doing this migration. I also don't think we are the slowest from what I hear. But yeah, it's a work in progress. Come back in 6 months. Another question over there?
I wanted to know how many countries do you support with the GetYourGuide, and is Egypt included?
Mm-hmm. So we have, I think we are operating in 14 languages. Arabic is not one of those languages yet. Nevertheless, it's something that we can add. In terms of localization, we've been localizing the site into many markets already, and we continue extending there. So in that case, you'll have to use the English site basically, or any other language that you want. In terms of the activities you can do, I don't think we even count anymore the countries we are in, because we are basically all over the place. We have activities in every major touristic destination, including Egypt, obviously. Have you done any activities in Egypt from GetYourGuide yet? You have to tell me which one are good there. I mean, I'm sure the Nile cruise should be a huge hit. Yeah. And the pyramids and whatever. So please try them out and tell us if they're good. That's always open for feedback.
Okay, I have a question. Which tools do you use for A/B testing, especially for mobile?
Very good question. It's we tried a lot of them. We have our own internal framework for A/B testing on the web. So it's mostly a cookie-based, nothing fancy. We've tried Optimizely as well. Okay. We don't use it anymore. So we use our internal tool for that. For mobile, we also built our internal tool. But it's we tried Mixpanel and not super happy with it. Tried a few things. At the end, you need some confidence into your framework. So we also validated with AA tests and things like that what we're doing makes sense, because that's super important. If you'll be wasting time if you are not learning with confident statistics.
Okay.
Any more questions?
Yeah.
Good. So thank you very much for listening, and have a good rest of the evening. Looking forward. That's a great idea. Branding, man, you're an expert. Cool. Thank you very much. Yeah. I'm sure we will put them. Maybe we do a blog article about the event or something like that. Should I turn it off or? Let's see.
So hello everyone. My name is Mohamed Radwan. I'm DevOps engineer at Blista. Today I'm showing you how to build CI/CD pipeline. So my name is Mohammed. I'm DevOps engineer at Blista. Today I'm showing you how to build CI/CD pipeline. So, in all of you using pipeline? So, today I will introduce you GitLab, and I will show you GitLab CI configuration, and what is the CI/CD pipeline, and what does mean immutable AWS deployments, and how we can create image, how we can test the image, and what is the configuration management tools, and also we deploy image, and we show you demo. Okay. So a GitLab, it's a GitHub based. It's a CI/CD platform like Jenkins or Traverse or GoCD. So I'm using GitLab for our pipeline. So the GitLab components, we have GitLab server, that's the hosting the service, and GitLab runners. GitLab is the same with Jenkins. If you have master, Jenkins master node, and Jenkins slaves, it's like GitLab runners. In GitLab runners, you can have user space. You can run in your laptop. You can run it in AWS. So, yeah. We are using GitLab to build images, for example, Debian image, or testing, or build Docker images, and then we can push to registry. Who knows this icon? Or what does that mean? Anyone knows this? Hello. It's two? Almost come. It's AMI, Amazon Machine Image. Okay, I will come in this. In EC2, you're using AMI. So normally if you're using Ubuntu, you choose AMI image. Okay, I'm coming to this point. So what is the GitLab CI configuration file? It's a YAML file, human friendly. It's in top of your repository. It's describing the pipeline. You can have stages in pipeline, build, test, deploy. You can define what stages you need, and it's reduce artifacts. You can use artifacts in any stages of your pipeline, and stages can run parallel. So, yeah, as you see here, we have CI as a stage and another stage, CD pipeline. So CI is continuous integration. Normally, developers is pushing your code to main repository, and then the build start, and after that, the test start. And if test is failed, developer try to fix it and push again, and all this workflow named CI. And if he want to deploy it in production or in staging or whatever development environment, if you're using pipelines, well, this means continuous deployment. But if the there is another also continuous delivery. If you after you build the image or build the package, then test is run, test is passes, then you can deliver the there is a continuous delivery. So next slide. Yeah, what does mean immutable AWS deployment? Immutable means when you creating AMI or creating EC2, you don't do any changes on it. So if you want to do changes, you're just creating a new AMI, and if you want to roll back, you use the latest the before latest AMI, and you can roll back. So immutable, you don't do any changes on the fly. All changes can be happen in pipeline. So in demo today, I'm using GitLab, and I'm using Backer to creating the image. The Backer is creating image for me, and SaltStack is configuration management tool that will install packages I needed. then it will create AMI, and after that, I create the AMI, I put it in AWS, and then I run Backer again to test this AMI by something named server spec. It's a Ruby tool, and after that, I create the latest AMI. I can deploy it by Terraform, and then Terraform can update my launch configuration in autoscale. Is this clear, or someone?
What's the difference between the first AMI and the second one? What changes?
Yeah, in first AMI, I'm using fresh AMI, for example, from Ubuntu, and then I install all packages I needed. For example, Nginx, whatever your app is, and I want to validate this AMI. So I'm using again Backer by server spec. It's one of the Ruby tools that you can define, describe. We can describe what it means server spec, but it will describe what cron job you have, what package do you need, and if it's success, then it will create a new AMI. So you can put this in one slide if you want. Okay. Creating image. We're creating image by Backer. Backer is open source tool. It's by HashiCorp company. And is any of you using Backer before? So you know Backer. It's not configuration management tool. It's using configuration management tool. It's creating, it's the same company doing background. The same company doing Terraform, console. Yeah, HashiCorp. Okay. And Backer is not replacing configuration management. It's using configuration management, and it's creating image machines, like for example, AMI for EC2 in AWS, or VMDK for VMware, or even cloud, Google Cloud, or DigitalOcean. Okay. Testing the image. This server spec I found it is very good. It's a Ruby tool, and you can write your test. It's not testing the code; it's testing the image itself. Packages installed, package cron jobs. You have a lot of resources type. You can use it. For example. Any resource type, you have it here. For example, if you say Nginx, you can type like this, should be installed. If it's not installed, it will not create AMI. Okay? So what is the configuration management tools? Is anyone using configuration management tools? So Puppet, Chef, Salt, Ansible. So all of them are doing the same goal, but it's different. Yeah, maybe in Ansible, you don't need the clients running in the servers, but you have one place you can orchestration your servers. But for example, Puppet or Salt Stack, you need agents in the client servers. And we're using configuration management to make sure our configuration is in all servers are correct, and also the rule of the server is correct. So, yeah, in configuration management, you have orchestration, automated provisioning, and code management and reporting. So I'm using here for my example, I'm using Salt Stack. Deploy image. I'm using Terraform for deploying image. So the question again, who is using Terraform? So Terraform. I will come to you. I'll come to you. So Terraform is a tool to build your or provisioning your infrastructure. For example, in AWS you have regions, right? And you want to create EC2, you want to create VPC, you want to create subnets, you want to create security groups, you want to create autoscaling. All this stuff, if you do it manually, sometimes you make mistakes, right? And if your company asks you, hey, I want to another new region, you can reuse the same code in a new region. So, yeah, but it's using CloudFormation. It's a good thing. It's Terraform using multi-providers. If you have Allium servers from Alibaba, you don't need to find another provider, another tool. Huh? Yeah, it's using node formation. Huh? The people stop me. I have no problem to the question between.
Please guys use this for the recording.
It's coming. It's coming.
I have a question here. Why you are creating a new AMI image instead of deploying the package in an existing infrastructure?
Yeah, this is a good question. And I'm using immutable infrastructure. Immutable means I'm not using the existing infrastructure. This means mutable infrastructure. So every time when I'm deploying new stuff, I'm creating new release, new MI, and destroy the old one. But if you mean the features between immutable and immutable infrastructure, it's a lot of features you have. You don't need to use the same components in your infrastructure. Okay, and you can scale your infrastructure.
So if it's a minor change, why I need to recreate a new infrastructure or a new AMI for this minor change?
Anyone has answer for this question?
I understand that it's pretty easier to manage a mutable configuration. So you can predict. I mean, configuration can be predictable, and it will be very easy to handle them in the future. You don't have to go back and remember what that image was, the version of the packages and all that stuff. So every time you have a new update, you just destroy the old one and create another one. So it's just a way for making the management of the images predictable and easier. So you just create a new one. So you don't have to manage the versioning of the old stuff. This is what I understand.
Also, there are some changes that you can do using the normal tools like Ansible and all these stuff. For example, sometimes if you are upgrading some critical stuff, for example, like glibc library or something like that, you can do it on the fly directly. It will create so much havoc in that state. So basically, you'll have to take it down, bring it up again. So there are some changes that basically can't be done using the normal provisioning tool like Ansible and Fabric and all this stuff.
Yeah.
So two questions. How long does it take to build an AMI? And is there any caching involved? Because I would imagine that if you have a minor change and then you need to wait until the whole thing builds all over again, it would be quite a long time. So is there any caching involved? That basically, if nothing changes in the machine configuration, we'll just take the code. We'll just take the code and put it inside the new MI.
So MI, it depends on your application and depends on your configuration you are using. For me, here it takes 12 minutes. Sometimes, if you're using the test, what I'm doing now, it takes more time. But I'm sure the test, I'm sure my MI has proper packages. So it takes around 12 minutes for my stuff.
From get push to production?
Yeah.
12 minutes?
Yeah.
Okay. And is there caching involved?
What do you mean by caching? Because every runner, you have every runner doing the whole steps again. When you trigger the build, it's building from scratch. If you want the artifacts, do you mean artifacts?
I mean,
the build is finished.
the file system of the machine has packages installed for applications and has code. So if you have not changed any packages, there's no need to change anything except for the code.
Okay,
I will elaborate later.
Yeah. So I'm showing you the demo. Very good. Finally. So this is my GitLab file, this YAML file, and I'm using this image like Ubuntu latest and variables. Okay, before I start to tell you what variables and Git this stuff, I will show you the pipeline itself. So this is my pipeline. This is my GitLab file, YAML file, and as you see, you define the stages, build, test, deploy, or these stages you can define by yourself, whatever you want. And before the stages start, you can run before script. I'm installing here Packer, I'm installing Terraform, and to build the AMI, I'm using JSON file, and I will show you the JSON file. So this first stage, build, and then you can define here if it's manually, trigger manually or trigger by automatic. If you make it manual, then we should have like play button to start it. Artifacts, which artifacts and when it expires. The second part, I'm testing the AMI, okay, and I'm taking this echo command to take the AMI ID and region and use it as a source. So, and build the AMI again, and the artifact is 30 days. You can define it. And deploy app, you can deploy in staging or deploy in production. In this point, I'm using Terraform for deploying, and I'm exporting my access key because I don't need to anyone see the access key. It's in GitLab CI. There is a secrets. You can put secret variables, and I'm using these variables as export here. So I'm doing Terraform initialization and then Terraform plan, and then I'm doing Terraform apply. So, anyone has a question? It's a GitLab CI script. In GitLab, you're using everything as a code. So, any changes you need to do, you need to do it in this file. Every time you install Docker and Terraform, you cannot just get that in the container. Yeah. Any questions? Fine.
How many releases do you have per day in your CI CD pipeline? How many releases do you do per day?
Yeah, but okay, I'm not sure if this is something for my companies to say it, but you can do it.
Okay.
What's the problem?
You do more than one release per day.
Yeah, you can do. We can do release now if you want, but not the hour. In my app. I don't get fired from my company. So
you should be fine, don't worry.
So next file, I'll show you. This is my repository, okay? And yeah, I have Terraform here. You can use submit views if you want, but I put everything in one repository. This not can be happening in reality, but you can use submit views because salt is not should be not in the app, and show you further. So yeah, this variable is for Packer, and you can define the builders. You can define the builders and the source of AMI. So in here, I'm installing the EC2 AMI tools. I'm moving or copying the friend app. This is my app, and copy it to home Ubuntu in the image. Then I copy Salt, the configuration management tools, to also home Ubuntu, and then installing Salt, as you see, and then also run high state in Salt. High state means run Salt to make sure all apps are installed, all packages installed. And yeah, as you see, it's Python package, and I'm using pip. So yeah, then the artifacts will be here at the AMI to be in this file, in JSON file. Is this slide clear? Which to find? Yeah, it's like one command line and there is another command. Like which other file? GitYaml, it's the pipeline, my pipeline. This Backer is building the Backer, the image itself. So yeah, this is my pipeline. In Jenkins, for example, you define everything manual, right? But in here, you define everything in file. Okay, you can use it. So, as you see here, for example, all the scripts. For example, here, as you see, I'm installing Terraform in the container, and then it's found the image, this Ubuntu image, this AMI, and then start to do all stuff for Backer. So it takes 13 minutes, the whole pipeline. So in stage you have this play button. You can move all stuff to once the build is triggered. You can do everything. It's automatic, or you can push the button if you want to. Even you can push the button here to build the game. It depends to you. So, for example, right now I can deploy a game. I'm not sure if it works or not. So. No. This is all this is all my stuff. It's not related to work. Yeah. For my project. No, just finished.
How long does it take in your work memory?
You can say this.
Yeah, it's around half hour. Yeah. But actually, okay, because some people say why not use Docker and use ECS containers, for example, and it depends on how your application is complex. Okay, so that's why I'm creating this AMI, and once we have any upgrades package, we're creating a new AMI and deploy it in production.
Are you using Docker?
Yeah, the GitLab runner is using Docker.
Why?
That's why GitLab runner is doing this. It's using Docker. I'm not using Docker in my. The runner itself is using Docker. Like in Jenkins, for example, in workspace, you can use Docker inside.
How do you avoid that?
Good problem. Good question. I can do this and play it again. Yeah, I can play it like this. Just play.
And that's why you use
yeah, infrastructure. The same. No. Okay, it's this only build. The deploying is running Terraform. Okay, and running Terraform it not take times, maybe 2 minutes. But you have another problem. If you have hundreds of servers or thousands of servers using old image, or you have the corrupted image or something, so you need to how to use the deployment is different between company to company, you know, or so you can go manually and terminate if you want. Yeah, but I didn't put it in the slide, so yeah, you can use this. You can have another load balancer, and you can upload this, the first part of second load balancer, and change the traffic. Or route 53 and change weight if you want to.
Do you have this load balancer deployment?
Not in here, not now.
It's not here.
Not now.
Ah,
but
okay.
you can control the time, okay? Yeah. Here, for example,
Already running out of your time.
Yeah. Why are you using AMI? What kind of pizza did you eat?
No, he asked it about the AMI.
You said that
He told them it come to you.
Have you experimented with working over to PCR and measuring time versus units or using AMIs?
What's ECR?
The Amazon Container Registry.
ACS.
Yeah.
ACS.
The container service in the computer.
Yeah. In ACS, okay, depends on your application. Again, our application is too much complex. Okay, so not for now we don't have time to Docker everything. So that's why we're using AMI. We do installing all packages and create the AMI, and then update the launch configuration. But yeah, this.
You personally experimented with it?
Personally, yeah, ACS I played with it, and autoscale, yeah. I'm normal DevOps. I'm not super stuff, but I cannot say it's easier.
What do you prefer? Do you prefer?
My experience right now in creating AMIs. So guys, yeah, that's it.
I have a question. If I want to have the same deployment experience with the existing server, but I don't want to learn.
You can use. Mm-hmm. Yeah, using, for example, DigitalOcean or other. Yeah, so you mean to create image by Packer to not in Amazon, huh? Yeah.
Your infrastructure? Yes, my infrastructure. If it's okay, if it's working, then I use the same image as good. So I think you need to build something that fits your infrastructure which will be the same as I think you need to build something custom for you, or find something that can actually do this for yeah, because I like 15 minutes to deploy something for this thing that's not acceptable in my company.
No, but this is not testing the. You're testing the whole.
I need something like this for testing. Oh.
What do you mean by this? Like what the continuous deployment?
It's not good. This is not good test.
You don't do continuous deployment or integration on local machine. Why don't you just?
It's not local machine. I mean local infrastructure.
This is where you may experiment with using ACS and ACR because actually the Docker image you can download in your local machine. If you're wanting to reproduce the behavior locally exactly as in production, so perhaps using ACS there would be more helpful because you cannot run AMI.
Okay.
As far as I know, they are not in an image format that can be used by virtualization technology and virtual box or something. So if you have a Docker image, you can run it with any run like engine.
Okay.
But actually, Packer or Terraform, you can use them with your own virtualization solution, even VirtualBox, that's the same, or KVM, whatever. I'm not sure about AMI, but you can you can use it with, you can replace the hypervisor with something locally, or OpenStack, VirtualBox, or KVM, or whatever. You just need to change in one area, and this configuration will work with the rest of configuration will work normally. That's.
But does Terraform like support something like
yes,
this?
Yes.
So I do the Terraform, and the Terraform
yes.
That
yes,
exports, create the images for my
that's the point
personal
of
virtualization,
yes.
right? That's good. Actually, I didn't know that.
Okay, I have a question. Okay, you mentioned in the slide that you are using Travis, but I didn't find it in the cycle. Yeah.
CI or CD tools, it's GitLab
this,
CI,
for example,
like
it's
Jenkins,
GitLab, like Travis, and so on.
Like
So,
GoCD. But,
so,
but Travis is not, I'm not sure, I'm not using it, so I cannot say. I used Jenkins before and used GitLab CI. That's my...
so the cycle is a start from you are commit your code in GitLab, and itself is also you build your pipeline with GitLab and everything, and with a script. This is okay.
In GitLab YAML file.
Okay, thank you.
I think we run out of time, so thank you, Mohamed. No. Guys, please, when there is a question, please use this thing, because for the recording, you don't hear yourself now, it's just for the recording, so we have a clear voice in the recording. Okay? Yeah. And I prefer if the questions are postponed after the presentation.
Hello, everybody. Can you hear me all?
This is just for recording.
Okay. Okay, anyway. Okay, I'll try. So, good evening, everyone. So, my name is Mohamed Baddar. I'm working as a data scientist at GoYoro in Berlin. So, my today's topic is about, I think it's a simple thing that we are using every day, especially in Berlin, which is forecasting. I think every one of us is using weather forecasting in Berlin because weather is very stable. So, somehow. So, I mean, today I would like to show you simple techniques for doing forecasting for time series data. So, in general, we are facing time series data every day. For example, the temperature for every day, every hour. And for example, if our forecasting sales for retailers, we want to forecast the sales for next few months or for next few weeks. So I thought this would be a very beneficial introduction to everyone who is new to data science area or machine learning area, because it has many applications I've seen in my career so far. So the contents will be, I will give a quick introduction to what is the application of time series data, and how to make a quick visual analysis, because usually the human eye is better than any machine learning tool for capturing the trend and data. And introducing some concepts for how stable is the time series, how we are modeling, use different machine learning models for time series, how we are going to some data pre-processing to make data clean, ready for the machine learning model, how the model are built, how it using, what are the statistical tools or statistical techniques behind building a time series model, and how we are going to evaluate this model, and a very simple demo to show you the steps that we will learn in this session. So, quickly, the applications of time series analysis can be in many, many pages, but it's economic sales forecasting, stock market analysis, user behavior analysis. For example, I think in GetYourGuide and GoYoro or any company, they want to measure, for example, for the trend for buying a specific product over time, is it increasing or decreasing or something. Weather forecasting, workload projection. For example, in the previous session, Mohammed mentioned how Amazon is a used for CI/CD. So, for example, Amazon and big companies for our cloud providers, they are trying to making load balancing by dispatching, for example, processes into specific server or another server. So they have to make forecasting ahead for the demand or the workload for each server so that they can make load balancing proactive. And census analysis, for example, if you want to measure the trend in a specific disease or a specific census phenomena, for example, the number of males or females are increasing, decreasing in specific area. So it has many, many applications in, I think, in many business and or areas of life. So before digging deep into the technical details of time series analysis, the main idea is for any machine learning model or time series modeling is systematically isolating each assumed component for the time series. So as you know, in the agile coaching, always telling us they are trying to peeling up the onion from outside to inside. So it's like you have this time series data or any any data from a machine learning model, you are just trying to systematically remove one pattern after another and getting it out of the data. And finally, with the data you have it's just random noise that doesn't have a detectable pattern. This is the main idea behind in machine learning model. I just wanted to emphasize this point before we go deeper in the technical details. So we will show the steps how we are going to remove the assumed pattern behind the data at each step until we try to model the randomness of the data into real equations that we can manage. So, for example, this is the classical textbook sample time series. It shows the air passengers demand for specific airlines inside the United States from about 1950 to 1960. So let's try to analyze it together. I mean, what we can see from this data. That's the first one. And the second one is, so that's the trend. The increasing part is the trend. But of course, this is a nice time series we don't see in the real life. So it's, usually, sometimes the trend is not that continuous. For example, it's increasing and decreasing. The first one. Second one, the part of the oscillation. For example, if you took each oscillatory part, we can see that the distance between the peak and the minimum is increasing over time. This is called the variance. So this means that the data vary a lot over time, and the average of the number of passengers is increasing over time. So we talked about the visual analysis, and also the second one, if we can see it in this example, but sometimes there's some spikes. These spikes are called outliers. So outliers come from two sources. First one is some error in recording the data. For example, if you have negative data for number of air passengers, of course it's an outlier. So we need to make sure that our data collection is correct. The second one, the spikes may mean some extra phenomena. For example, if there is a storm in some state in the United States, so maybe at this month the number of departing people trying to escape out of the storm is tremendous. So the outliers, so if we just can detect them by eye and handle them in a separate way, it will be better rather than just pushing all the data into the machine learning model. So I will try to give some statistical concept behind the time series analysis. So it's called stationarity. Stationarity means that the time series is stable over time. So don't bother yourself with the equations, because I know it's I just put them for reference. But it means that if we want to look at this time series, stationarity means that the characteristic of the time series doesn't change over time. So if you are looking at this time series, the first characteristic for any statistical random variable is the average with the mean. So for example, if we took the mean of the time series for the first 2 years, it will be far different from the period of from the average of the time series for the last 2 years. So this means that the time series is increasing over time. So the first part for any machine learning model is trying to remove this trend. It's like detrending, or if you remember from college mathematics that we if we have a linear equation and you get the first order derivative, it converts to a constant. So this is like here. So If we just model it like a linear line and we took the differencing, I will talk about difference later, or in general, some mathematical process, we are converting this time series from an increasing one to a stable one. So this is the first step we do in any time series. So does anyone have questions? Because we are getting some real technical stuff.
Yeah, but this is just happening in. So, this only happens in the time series that have trends. Like,
no,
what if there is like several different?
Yes, there are
trends?
several characteristics, but I just wanted to take the simplest one. So this is a good question. So I mean, formally, if you recall from probability that there is a joint distribution, that how all the values are distributed together. So this means that the mean is the same, the variance is the same, the third moment is the same. So all the all the statistical characteristics of the data are the same. But for feasibility, that we cannot measure all the statistical characteristics, we'll show the mean and the variance should be the same over time. By this, we can define stationarity for the data. So this one is about the formal mathematical definition of strict stationarity, that the distribution of any window of the data as we move over time should be the same. But for weak stationarity, as Hisham said, that we should also, for any window of the data, if we measure the mean and the variance, it should be stable over time. So this is the first step, or the first check you have to know in the data. So if you know your data is not stationary, it's increasing, or the variance increasing, so you know you have some stuff to do before building your model. So what the model is some assumed equation or some assumed pattern in the data. We assume and we try to fit our data into the pre-assumed model. So one of the famous models for time series is the error, trend, and seasonality. So we are modeling our time series data as a combination of three components. These combinations have different forms, but let's just think about it as a general combination. So the first combination is a trend part. So this means that the time series is moving over time. So the second combination is the seasonal part. So this is the monthly data over year. So by seasonality, we mean that, for example, the number of air passengers are moving is in January is high, but for example, in June is very low, and so on. So by seasonality, we mean the average increase or decrease for this specific period of time relative to the average. For example, we can say that in January, people are traveling 50% over average, or in December, people are traveling 30% below average. So this is not works, because it helps in the modeling, and also it helps to describe the results of the statistical data to business stakeholders. So let's talk about the different combinations. So as I mentioned, that we are assuming that the data are a combination of the trend, the seasonality, and the error bar. The error bar is, for example, if we are having time series that by that we mean that YT, or the value at each time point, it will be sum of three components: the trend component, the seasonal component, and the error component. So it's like that the trend represent the average at this time point, for example, 100 passengers, and the seasonality at January is also 100. So this means that we are expecting at specific time point that the number of passengers will be 500 over 100 seasonality, it will be 600. And the error term in statistics, usually we hope to be some kind of white noise. It means that's random process that have zero average. It should be zero, but in real life, it's minimized to be as much as possible near zero. So this is one of the major models that are used in the time series analysis. So any questions? Sure.
What you are mean by the error number, or what exactly it represents?
It represents how far our model is far from reality. So, for example, if we are saying that the number of passengers at a specific time is sum of two values, the trend and the seasonality at this part, but of course our model will not be perfect. It will not fit our data 100%. So, for example, if we are generating data from our model and plotted, I should have made it, of course, but if we plotted our fitted model against our time series model, you will find some difference in this difference. We are hoping this as minimum as possible, if zero.
Over the real calculation or below the real calculation?
Yes, just sometimes they are taking the sum of the squared error just to remove the sign effect. Also, one of the more complicated model for time series, but we're not talking about this in this session, it's called the ARIMA model. I will just give an intuition how it works. So in our previous model, we are assuming that there is a trend and seasonality. But there are other intuition behind forecasting. For example, if the weather today, the temperature is 13 degrees, we are expecting tomorrow it will not very far from 13 degrees. For example, it will be 14, it will be 15 or below that. So that's it's called an autoregressive integrated moving average. Regarding the nice name, autoregressive means that each value is dependent on the previous value or previous values of the data. So it is especially useful for modeling natural behavioral data, like weather, like other natural behavior, because in natural behavior we don't see the spikes, like, for example, the stock market analysis or these things. So this model is trying to, does anyone know about, simple regression equation or something? No, it's yeah. So it's the idea is very simple. I just don't want to bother you with the equation that we are assuming that each value at each time point is a combination of the value of the previous time intervals. But for this slide, we are just focusing on the trend and seasonal analysis. So before now, we have learned that our time series should be stationary. By stationarity, we mean that the trend is the same, and the trend is removed, and the variance over the seasonality is removed. So there is some equations or some transformations for the data that help us stabilizing the data or stationarizing the data. So the first one and the simplest one is the log transformation. The nice thing about the log transformation is, for example, if you looked back again at our example time series, we can imagine that if we are drawing some straight line right here, that the seasonal index has a multiplicative form rather than additive form. By multiplicative form, that, for example, if you are saying that the seasonal index means that at January, it means that people are traveling 1.5x above average. So if the average is 100, so the seasonal index will be 1.5 multiplied by 100. If the trend or the average at this point is 200, the seasonal index will be 1.5 multiplied by 200. So the seasonal index is multiplied by the average, is amplified by it. So the multiplication part should be removed. So the nice thing about the log transformation that it transforms the multiplication operation to an additive operation. So if we'll also see this in the demo in the end of the session, that by taking the log of the data, we are making the seasonality more stable. One also one of the commonly used data transformation is the moving average. The moving average, by moving average, we mean that at each time point of the data, we are making some smoothing. For example, if the data have many fluctuations, many transients, so the moving average, it says that the value at each time point will be taken as the average of the window surrounding this time point. For example, if you are standing at this time point, we are just taking the window around it, and the value at this point will be transformed to the average of the window surrounding this point. So the nice thing, as we can see in this example, we have sample data for the birth rates in the United States over about 30 years. So if we remove this red line, we can see detectable pattern. We can see detectable trend. But by applying the moving average, we can see that the red time series is more smooth and can tell us some long-term information. So we can say, for example, from 1915 to 1960, the birth rate is increasing. And from 1960 to 1970, it's decreasing, and so on. So moving average helps to remove the transient fluctuation of the data and gives you more overview about how the data behaves. So now we talked about the stationarity of the data and how we can handle the increasing variance in the data. The next one will be about the differencing. So by differencing, we mean that the value at each time point will be taken as the difference between the value at this time point and the value at the previous time point. So regardless about the mathematical definition, differencing is used to remove the trend of the data. So as we will see in the demo, by plotting the data after differencing, we can I can show it to you right here. So, I mean, this is the sample data we already have. And this one, after removing the seasonality, will show how to do. I will show you how we remove seasonality later. But from this time series to this time series, we are taking the difference. But the difference means the value at each time point is just the difference between the current value and the previous value. It's like taking the differentiation of a linear equation. So in this, in the rightmost time series, we can see that it is just there is no trend, just constant trend. So at this point, after removing the seasonal variance, after removing the trend, we are taking this signal, and you are hoping that this signal is just a random noise. By random noise, we mean is that we are taking the average of all these time series. It should be around 0. So it means that there is no other detectable pattern we can take from this data. So also, we talked about the differencing. So the seasonal adjustment, as I mentioned, that we are taking the seasonal index. For example, January, you are saying that people are traveling 1.5 over average. So by dividing each value over this seasonal index, we are just removing the seasonal component of this time series. So so any questions so far about? Sure. So, yeah. So the benefits. So the benefits. You mean what are the benefits behind this equation for forecasting part or in general?
In general for a company.
Yeah. So the benefits that, for example, let's talk about a traveling business, for example, in GoYoro and GetYourGuide. So, for example, if we want to know the demand for a specific route or for a specific ticket for a specific hotel, so at specific time points, we are expecting the demand to be very high. So we can show our users that, like the feature in the booking.com, that he is telling you that the demand at this time for this hotel is very high and tickets are running quickly. So, for example, we have some internal rule that if the demand is increasing by about 20% or 10% for this hotel, we should tell people that they should run quickly and book this ticket. For example, in traveling, if the price are going down for some tickets, and we can tell the people that you can wait. The price are expecting to go low for these tickets. Or at a specific time point, if we are expecting price are going very high, we can set some alert and telling them, hey, next week we are expecting the tickets for this specific trip is going very high. You should book right now. So expecting the future behavior for people for whether for whether it's very general. I mean for expecting future behavior for people can help telling user what to do right now, because user never know what's going next. I mean, when I see, for example, a ticket for 40 euros, I say, hey, it's the ticket price is very stable for 2 weeks. But from our data, we're expecting that in the 4th week, the tickets, the demand will be very high, and the ticket price will be for about 80 euros. So if we just benefit our customer and told them, hey, you should order this right now, this will be beneficial to user, and make them trust us more, that we know what we are doing and we know what we are suggesting to them.
Okay, and the input is search results, or actually one is going to buy?
It depends. I mean, usually several kinds of analysis are performed on the searches, on the click-outs, on the bookings, because, for example, high search for a specific ticket doesn't mean the high booking for a specific ticket. For example, people just search because they want to know about what is the price. For example, the booking for this specific provider, this specific hotel, we are not integrating well for the Visa card or the paying method for this hotel. So we are trying to separate the analysis for searching, for clicking, and for booking. Gotcha. Sure. Okay. So next.
Sorry. If you could go back one slide, just to make sure I understand. Like in the last graph, you say you have basically random noise, and that's what you want. So basically, this is if you manage to predict like seasonality and the trend, then it's only the random error, and you will never get rid of it, right? Is that the reason why you want that to be like noise?
I mean, if we are assuming that we are working with this naive model, this is what we are hoping for. But for example, if we are using more complex models, I mean, for more complex models like ARIMA, we are just taking this noise and we are applying other machine learning model for them. For example, auto regression, dynamic regression. So we are, but for this simple model precision, we are just hoping for this to be the guide.
Thank you.
Machine learning could be applied for any software. What I'm trying to ask here is, what's the main criteria that you could measure to detect whether your software needs machine learning or not?
Yeah, I mean, this is a very big question. I mean, it can take years to answer, but I mean, let's, as far as I know, there are two main players in this market, R software and Python software. For example, Python is very readable. Many packages can be integrated to large framework, for example, like Spark, like Hadoop, and etc. But in my opinion, Python has lack of statistical libraries. For example, in R, you have a very wide range of statistical machine learning tools. You can just prototype your idea or your custom machine learning model in 1 week. But for Python, it may take more time. But the disaster happens when you are trying to make R production ready, because R is not designed for engineers anyway. So the best way, I mean, is trying to try small model using R. We are trying to prove concept, and then we're trying to make in production or using Python. So it depends on what phase of the project you are. If you're just trying to make a proof of concept, discover new things, and sometimes your data is not predictable. You can find some pattern. So you won't bother making something production ready that's not useful. So for me, R is very useful for prototyping, but Python is more way production ready than R.
But you can implement all your data, make all your data analysis on the remaining, like the whole thing with Python, or you include other tech?
Yeah, for me, I think Python, because, for example, the main problem is handling large data, and the main framework these days, I mean, Spark, like Hadoop, and all these frameworks have some interface with Python. So Python is just magic for handling data science projects in production. But the problem is that and it just usually happen, that you can just grab one of the shelf algorithms, one of the packaged machine learning algorithms, and use it to analyze your data. You have to use a combination of them, doing some data preprocessing, doing some customization to the machine learning model. R helps in this a lot. So it helps you to get your results quickly, to remove the risk of the project quickly. But at this point, when you are trying, now we are stable, now we have the model and the data processing, now we are knowing now we know what we are doing. The next step is just remove ROA and rebuild everything from Python. This is the most safe way and time, what can I say, time-saving way to do these things.
You are referring that you can make combination of between R and Python for one platform or?
No, I'm not for about the. No, I mean, of course you can make whatever you want, but I think that at some phase, I mean, at the prototyping phase, at the risk removal phase, it's better to use R because it's quickly to prototype things, and when you are moving your model to production, it's better go to Python.
Okay, so you mean R is much better for
prototyping and experimenting,
calculations or stuff like that?
Yes, of course. So have many.
Python is
more. If you want, already you have a model and you know what are the techniques you are using, you want to go to production, so it's better to use Python.
Okay, thank
you. Okay, I'm curious about how did using time series influence the product in GoEuro? You don't have to reveal any confidential information. Just how. A sense of numbers. How did
I can't say numbers to be honest.
Okay.
I mean, I'm sorry for that. That's it's legal issues.
Okay. I have a question. After you already done with your model and integrated this, how can you do the testing needed for this model in real environment, not just a model, but like a real application?
Yes.
How do you test this?
Yes, that's a good question. I mean, I was just about talking about this. This will be the last slide, but I will answering it in an abstract way. So for any machine learning model, the basic so by testing, there's two types of testing: the technical testing and the business testing. Because at some point, business people telling this is nice, what we are going to this, how we are performing, how we are measuring the performance of this. So the first part is the technical testing. You are dividing your data. For example, if you have this time series. We are just getting the data until 1958, the data input to our model, and we are trying to optimize our model and making prediction. And the next step is to compare our forecasting, our prediction to the test data, or the part we have hold it out to test our model.
You are using some of your already data?
Yeah, as a training.
As training, and then you compare this with real data?
Yes, I mean, and there's some more complicated schema. For example, you are dividing your data into three parts: the testing, the training, the validation, and testing. For the training part, you are just building a model. For validating, you are just benchmarking a model, seeing its performance. For example, tuning some parameters using different models. But as you are touching some of the data to build your model or tweaking it, it's called dirty data. You can use it for testing. So here comes the third part. You are just using the third part to report accuracy to managers, to business stakeholders. So this is the most stable schema for training, validation, and testing your data against several models.
Okay, this is on the technical level, and then after integrating this into your application.
You mean how to test it? You mean the part of software testing?
Yes.
Yeah, I mean, usually it will be that we are having some training data, testing validation from for example, from R, from Python, and we are including this data in unit testing, so that for each production release, we are making sure that our data are giving us the forecasting we have got from R, from Python, so that the data transformation, for example, loading from database doesn't make any errors. This is as far as I know software testing. So as I have 5 minutes, as Ashraf told me, the last thing is, I will skip this because it has many questions. So one of the techniques used for forecasting is the whole two-winter model, but we don't have time to dig into this. But simply it just tries to combine the seasonal pattern, the trend pattern, and the error pattern, tries to minimize this error and make it as random as possible. So this is just a demo for building the whole winter model for the forecasting data. So the red time series shows the fitted data, or how the model are estimating how the model are generating the data for this time series based on its equation. And the black time series shows the original time series. So at this part, we are showing a happy case that the model is fitting our data almost 100%. And this is the sample forecast. Now we are telling the model we want to forecast the number of air passengers for next year. So this is sample output for the data. And this is just quick visual testing for our data. So the x-axis will be, the x-axis is the log transformation for the forecasted data, and the y-axis is the actual data. So this is scatter plot, as most of the data are lying near the 45 degrees line. This means that most of our forecasted data is nearly the same as the test data. So this means that the model is good. But if the data visually is far away from this 45 line, this means that we need to improve our forecasting. So just to sum up, if we are going to approach time series modeling, first one is try to plotting your data, try to capture the trend and seasonality, check if your data is stationary or not, making data transformation to make your data stationary if it isn't. There are some techniques for extracting the season and the trend component. We can discuss this later. And residual checking, if your residual of the error data is just a random noise, so we are good and our model is perfect. And separate data into training and testing. Yeah, and that's it. Yeah, thank you.
Last question, because I'm sorry, just took some time.
Sure.
Okay. So I wanted to ask about the seasonal index and how do you
measure it?
Exactly.
Yeah. For example, I mean, we are trying to measure the seasonal index for January. So we are taking now we have the trend data, the straight line that shows how the data is increasing. So we are taking the average value for each January of our data, and we just dividing it by the average, so that in this case we are saying that our sales or our number of passengers is above the average by this index. This is a naive way. I mean, there are more advanced ways, but this is in general how it works.
Okay.
Sorry, one last question. Now you have your model and you have a running system, and the system keeps giving, for example, recommendations for users, and then the system keeps getting new data, like real future data. But
how we are going to get this data into the new model?
So you adjust the model. I mean, what do you do? Do you monitor your model, and how you do this?
I mean, to get new data into an existing model, there are two approaches. I mean, the first approach is just getting the new data into the existing data and retrain the model for the complete data. It depends on what type of problem. For example, for forecasting, usually we drop the very old data because the machine learning model for forecasting, by design in the equation, it usually drop the old data. So we are dropping it to save some computation cycles. But for example, there are models that are called incremental. For example, we are building a model for the new data, and we are trying to incorporate the new model with the old model by combining the two equations. So based on what is the cost of building the new model, if the cost of building a new model is just 1 day, for example, it's no problem, because usually these models are running in patch mode. We are just updating our model, for example, for every week, for every month. But for some kind of business like stock market analysis, you have to update your model every hour. So in this kind of model, you have to some incremental model building, because you don't have to rebuild your model for all your data. Because if in stock market analysis you are building a model in 1 day, you are just losing millions of money, because no one waits for 1 day in stock market analysis.
For normal practice, you just have like some sort of monitoring that gives you alerts.
It's like a batch
spikes or anything. Like
alert that the accuracy of model is degrading now. So now you should either rebuild. If rebuilding the model solves the problem, it's okay. If it's not solving the problem, we need to remodel our system. Yeah.
Thank you.
I think. Of course.
Coming to the last exam?
No, not yet.
Thank you.
As in Vic? 5 دقايق. حد عايز 5 دقايق؟ مفيش؟ كله عايز يكمل؟
مش عارف. السلام عليكم. Sorry, I couldn't resist seeing all of those Egyptians in one place. Is really so. So hello, my name is Youssef Mahmoud. I'm working as a software engineer in Zalando Payments. I came to Germany like almost 2 years ago now, and today we are going to discuss. Yeah, after what Mohamed presented, this will be most probably a boring topic, and yeah, but we don't need all the topics to be interesting. So what the title really is here may seem like something complex or advanced. However, it's really pretty logical, and you might be doing this or part of it or all of it in your daily working operations. So first of all, what we are going to talk about is mainly reliability. So defining reliability in a very simple form, that means simply to continue to work correctly even when things go wrong. So you can define reliability when you go every day to work, although you have some problems at home or at your life or anything like this, and you still do your job, you still do your work. This is reliability. The system, your systems are continuing to be operational in a nice way, in an acceptable way, maybe not in the very best way, but simply an exception or a problem that happens will not really fail all of your systems. So what is this? This is part of the microservices world that we have in Zalando, but it's the same in almost every place that implements microservice architecture, and this is only part of it. So what you can see here is some communication lines between some services, some databases like in here. This is, for example, this is AWS, some cloud systems here may be used for whatever. So it's like a very complicated, it's not complicated in terms that it's complex, but it's like a lot of communication lines and a lot of interactions between different systems. So this introduces some reliability problems. Why? Because now previously, when you're building a monolith, for example, which something that I think all of us did at some point, you just build an application, put it on a server, either in a cloud or most probably at that time you put it in a data center. If the application goes down, most probably you have another application running somewhere that will take over. The load balancer will do some stuff or something like this. But at the end, the whole application that failed just go down, moved away, and then you do the magical solution of restarting your service or restarting your whole server and all of those stuff. But when you're having such a landscape of microservices, you tend to have different problems. Now that every system of those is totally independent, it has its own dependencies, its own storage, its own databases, and also its own service level objectives. So some service can get you the data that you want in like, let's say 1 second, which is really, really long. And some other service can really work very fast, like in 3 milliseconds. It depends on the use case that the service is fulfilling. So, and more frequent deployments. As Mohamed explained about this CI/CD stuff, and actually moving on making deployments easier and easier, doing them more frequent, then it's really, really highly applicable, highly probable that some team will mess up or break up something at one day. So some developer was just sleeping or something and then click deploy before going home, and then this will trigger a lot of problems that you are not really expected, are not really expected to happen. Also, depending more and more on cloud services, that means that you are basically outsourcing or depending on some external service. Even if its name is Amazon, it can fail. You depend more on S3. From time to time, you wake up in the morning and see that
S3 failed, and then half of the internet is down, or something like this happens. So this is because failures will happen. Even if it's most of the time is reliable, it will fail at some point. And this also the complicated service intercommunication. I mean that you provide us a microservice in a world like this, and you don't really control which other service is consuming your data. So, for example, you provide a service with a REST API. You define your Swagger file, right? Okay, if you want to get the specific type of data, you need to pass parameters 1, 2, 3, and you just leave it in this universe. And then some other team at some point thinks that they want to build some solution, and then they will search, and then they will find that your service is providing this. So they will communicate with it and get the data. So you can actually get many consumers of your service that you don't really plan every time you add a new consumer. You just get them to use your service. And you're not really doing this in a controlled manner. So what we are going to discuss today, which is, again, is really logical, and I think we do it all the time, part of it or all of it, is how to make sure that this can still work even when some parts fail. And we need to design our code keeping in mind that it will fail, no matter what. What happens, your service will fail at some point. So you need to design your services and your code keeping in mind that failure is, I'm not really sure about the word, but imminent. It will really happen. So now, I was a Java developer, then a Python developer for some time, then Java developer again. So I will write some code here that is neither Java, nor Python, nor pseudocode. But I hope that you get what's happening. So now we are writing some code, a piece of code somewhere that needs to fetch some data from an external service. So this is a function that is named do external call, which is really, I think clear. So now we are saying that we need to design our coding, our retrieval, our communication with external services with failure in mind. So now I need you all to just wake up a bit and tell me what will happen if this call fails. What? No, it's like this. There is some code in here, and this external call. What if this fails? What will happen?
So there's some code below won't run.
No, it's as it is. It's like plain as it is. It's asynchronous. This is a line and just lines. Okay, so an exception. Okay, a nice exception in the logs, and you just need to go. Okay, let's say that we want now, since we have worked on this slide before with the microservices, and we put failure in mind, this might fail due to many reasons. Maybe there is a network problem, and maybe this network problem will get solved by itself magically in the next second, or in the next, if you try again right away, maybe it will get solved. So how do we prevent this, or how do we prevent failing only because this failed? Okay, that's pretty logical. We will try again. So how many times or for how long do you like to try?
Waiting a bit longer and waiting a bit longer.
Yeah, in the term of trying to take your response time. So if you agree about specific response time, and you shouldn't be waiting more than this response time. So you shouldn't be waiting more than the agreement's response time for your service. So if this block of code is executing some response you are expecting within specific timeout, so it shouldn't be waiting more than this timeout.
Okay, I will take this part. We'll come to it, which is perfectly right. But I will take first the retries. So what you will do is something like this. So you will add those white lines, which is very stupid logical lines. That number of lines tries equal 1, and you will trace that. You will do it. If it fails, you will go into this exception block, and you will increment this. And then if you get above this threshold, you will throw an exception, which is, what's the guys mentioned now is that, you will need to wait for some more time, because if you do this right away, you still didn't do anything, because this will execute very fast, and then you will still may get the failure instead of just waiting for some time. So you will add some kind of a backoff that you will execute the retry and then wait for some number of milliseconds or seconds or whatever based on your service. And then you go into here again. If you still exhaust the number of tries, you will throw the exception. Okay. And how can this lead to problems? Now I need you to imagine that the previous slide. You can just put yourself, and anyone in Zalando, please don't answer. So it's like you're living in a world of a huge number of microservices, and now since you are living on AWS, it's really easy to scale your service. So, okay, we have a problem. We have a Black Friday. Let's scale this to 50 instances, get this up. And this service, and then there is a network problem. This service will try to, all those instances will try to get some specific information from some other service. And since you don't really know how this other service is installed, the setup of it, how it is done, you can't assume that it will also be like 50 instances and it will be really happy and can accept all of this load. You need to keep in mind that every service is different. So how can this still cause problems? Exactly. So you will back up for some time. And this, let's say that it starts from a request that's coming from another service, which triggers this code. You will back off, retry, and then you stop, and then we have another thing, back off, retry, and go and such. That can cause some kind of you can DDoS your own services because you just try to load them a lot. If there is a network failure, a lot of requests can just queue up, and when this other service is up, at this same time, a lot of requests can come and can go down because of developer problem. So first of all, we will name this pattern as retry. It's perfectly logical. So the other thing, to handle this other problem of not doing a lot of calls to service that you know is failing, you will introduce something as a circuit. What is a circuit? You just need somehow to know or to say somewhere that you know that this external service is failing. Okay, don't push it, don't request from it now until you somehow decide, okay, this service may have recovered and we can go for it again. So let's start from here. If you exhaust the number of tries, you will open circuit. What is open circuit? It's like you will maybe save it to some static variable or maybe write it to some kind of a file or something that you say that this service is not okay now. Don't really do any calls to it. So for the first time, you will open the circuit, throw the exception. The next time, if you find that the circuit is closed, which means that this service is fine and is responding, you will do the external call. But if you know already that this has just failed most recently, you will just fail fast. You don't need to issue the request to the external service, wait for it to fail, and then you fail, but you can just fail fast. You can just do it right away. So this is called the circuit breaker. The pattern is called the circuit breaker. How can this still be optimized?
You give the circuit call, you need to open it again at some point.
No. Yeah, that's totally fine. But I'm just not talking about this for simplicity. Let's assume that some other piece of software is running in the background for some time and will close the circuit when everything is okay. But I'm just talking about this piece of code. How can this still be more optimized to work even better, to be more reliable?
I think bootstrap code can time out and take like 50 seconds. So maybe having a limit around the bootstrap code. So after a second, you just time out and then you mark that it.
Okay, this will lead to an open circuit at some time, right? Okay, this is a good optimization, but there is another thing. Try to think of the whole system state. That's also possible. I'm just here putting 3 for like simplicity, but you can configure this, or you can actually do some kind of some magical code that will add number of retries, but at the end, the total result is the same. When an external service is failing, you will fail fast. Just imagine if this code is being executed as a part of a startup of a service, and this service needs to fetch some configs from a Zookeeper cluster somewhere. And it goes to try to get the configs from the Zookeeper cluster. The Zookeeper cluster is crazy as usual. And then you get the stuff first, you try to get it, you can't. and then the service will not be able to start up. Fallback. Exactly. Yes, which is a fallback. A fallback is some kind of the minimal acceptable behavior or the minimal acceptable things to be returned or to be dealt with in case of failure. So in this case of configuration, for example, you can have a backup configuration file or the last configuration file that you fetched from this remote source. So you will just do a fallback. If you find that the circuit is open, at this, of course you can change this, but this is just to try to imagine the situations. If you find, instead of just failing fast, you will just do a fallback, return or deal with the situation based on the specific case. So this is called a fallback. This is the third pattern.
But fallback is always an option?
It depends on your case. Actually, that's what I was about to mention, that every scenario of those needs to be really specific for specific coding. And you need to do this specifically for each service and each scenario. Sometimes you fail to get a config. Sometimes you fail to update a remote service. Sometimes if you're having an architecture that depends on some event sourcing stuff, you need to publish an event that triggers some change for the customer data, for example. If this fails, that's a problem. You need to keep doing it. So the fallback and how you deal with the fallback is really different from case to case. So the three patterns simply, without any surprises, retry, circuit breaker, and fallback. The question now is, every time I'm coding a service, do I need to code all of this stuff every time? And this answer, I think, is clear that no. Why? Because we have an open source community, and we have Netflix. Netflix is always living in this stuff of types of software, like introducing KS monkeys and doing all of those stuff. This is one of the things. Hystrix is just a framework that simplifies all of the things that we've talked about, which is totally logical. It's just giving you some configurable, easy way to use or to apply the patterns that we just spoke about. So, for example, the whole code that we written before can be something like this. So I omitted now the constructor and the other stuff, and simply that you will do. This is the run. This is the piece of code that will do the external call and any other logic that you like, but it's preferably to have only the code that will execute the external call, and then you can specify here the fallback. This is, of course, a very simplified snippet, because in Hystrix you can control much other stuff to do and so, but this is mainly the core idea, the concept, is that you need to run an external call, and then what happens if it fails, you do a fallback. The others are all configs that you can configure Hystrix. So you can configure some kind of command keys and command groups to get some statistics about how many times the circuit was open, how many times this call failed, and so you can have those statistics also to be useful in analyzing how the services communicate together, and if you have some kind of an SLA of another service, you need to keep an eye on it. So yeah, that's it. So thank you.
Mentioned that every service should be independent from the others, but what if you have, for example, at Zalando the payment is failing, and then the other services are actually dependent on your payment, right? And this means your whole thing, of course, not the whole website is down, but your payment is failing, and this means you don't have any payments happening in this time. So so they are dependent on payment service at some point.
Although we are now discussing some specific microservices stuff that can take a lot of time, but actually the question that you said now, I use this for interviews, which is really logical. We have a payment, we have Zalando getting payments from the people. And I will not really tell you what we do exactly, but it doesn't really matter because it's up to you. So for example, I can tell you some of the discussions that happened between me and one of the applicants when I asked such a question. So he said, okay, if this fails, we can get this request from the client, save it somewhere for later processing, and just tell him, okay, we accepted your offer and your payment and everything is fine. And then you try later on to get the money. And if it fails, send him an email telling him that, okay, that didn't work. That's an option. All of those options and how you deal with this is totally about your system specifically.
Yeah.
How can you deal with it? So yeah.
Okay, thank you.
Thank you.